Hey, hello everyone. Welcome to Q Physics Academy. This is our lecture number 6 of quantum mechanics. Actually, we are continue our lectures of simple harmonic oscillators, right? In previous classes, we are discussed how to calculate the eigenvalue and also calculate the uh, concept of raising and lowering operators, and also we calculate when lowering and raising operators acting on a state, then what actually we get, what the eigenvalue, what are the eigenstate we actually get. This all kinds of concept we are actually discussed. Okay, if anyone are not seen, not see, uh, anyone not, if anyone not saw those lectures, please go back to my channel and search my playlist of IIT JAM 2025. Click on the quantum mechanics series, and then here you definitely get all lectures 1 to lectures. Then we come to lecture number 6. Okay, in lecture number 6, we actually discuss the expectation value of the operators. Okay, right. In details, actually, in details, we have discussed in this today's class. The previous class, we actually discussed some uh, basic, basic concept of this expectations value of this positions operator, momentum operator, right? So let's start our. First of all, I think this okay. Okay, okay. So now we continue our lecture series of how to calculate the expectations value of harmonic oscillators for different states. Actually, we discuss here, right? In previous classes, we actually discussed the how to calculate the expectations value of positions operators and momentum operator. Hmm. But in today's class, we discuss the expectations value of the square of positions operator, square of momentum operators. Uh, okay, so you know the positions operator and momentum operators in terms of lowering and raising operators. We have already deal with these problems, right? So positions operators and momentum operators, positions and momentum operators, positions and momentum operators in terms of lowering and raising operators. In terms of lowering and raising operators, actually denoted as x cap equals to h cut upon 2m omega a cap plus a cap dagger is equation number 1. And momentum operators, it's equals to minus I m omega m cut omega upon 2 a cap minus a cap dagger. These two equations we are already discussed in previous classes. How to get, actually, lowering operators and raising operators, right? And this lowering and raising of from these two lowering and raising operator equations, we just some deal with some basic algebra. basic algebra, and we get these equations. Okay, uh, we get these equations. So this is not a very difficult process how to get this type of equations. You definitely do it. You go through my lectures number 5. You definitely got it, right? Okay. Okay. Now we calculate the square of positions operators. Square of positions operators. I mean x cap square. It is equals to h cut upon m omega a cap plus a cap dagger into a cap plus x. This is the actual way to write a operators, square of any operators. This is equals to h cut upon m omega, and this is equals to a cap square plus a cap into a cap dagger plus a cap dagger into a cap plus a cap dagger, right? A cap dagger and a cap dagger a cap, these two are not a same case. Okay, these two are not a same case. Just uh, remember this case actually. Okay, this is not a same things. Just remember a cap daggers not equals to a cap dagger a cap, because these two are the operators. For any operator, for any operators, a cap b cap is not equals to b cap a cap. You already know about this, right? That's why. So we get the momentum positions operator square. This is equation number 3. Now we calculate the what is the expectations value of this positions operator square with respect to any state. Now expectations value of x square with respect to, we are calculate here expectations value of x square equals to n x cap square get. So this is equals to what we get actually. We get actually x cap square. Just substitute this value h cut upon 2m omega n bra into a cap square plus a cap dagger plus a cap dagger a cap dagger a cap plus a cap dagger square. Okay. Okay. Just solve the mathematics. It's a very easy, right? This is very easy process. Right? This is a very easy process. Okay. This is equals to h cut upon omega. This is equals to bra n a cap into a cap kitten plus bra n a cap dagger kitten plus n a cap dagger a cap cat plus n a cap dagger into a cap dagger. The way to write, this is the way. You just calculate one by one, you get the results actually. Yeah. So we just calculate here. Calculate here. This is equals to h cut upon omega. So when a cap dagger acting on n state, what we get? n this is equals to root n a cap n minus 1 plus n plus 1 a cap n plus 1 plus n root n a cap dagger n minus 1 get plus n 3 equals to root n plus 1 a cap dagger. You just follow the step-by-step process, you definitely get the results. This is equals to h cut upon 2m omega root over n constant term. So this is equals to 8n into okay root under n minus 1 into n minus 1 minus 1 plus root over n plus 1 into raw n is equals to root under n plus 1 into n. Okay, plus root n n this is equals to root n into k10, right? K10 plus root over n plus 1 n into root n plus 2 get plus 2. Okay, so we get finally a very beautiful results. This is equals to h cut on 2 omega is equals to root n into n minus 1 ra n get n minus 2 plus n plus 1 ra n get n plus n ra n get n plus root under n plus 1 n plus 2 ra n get n plus ra n get n plus 2. Okay, I think you get a very good result. I think you get a very good result. Okay, so this is equals to you get h cut upon 2m omega h cut upon 2m omega is equals to root under n into n plus 1 delta n comma n minus 2 plus n plus 1 plus n, because this part equals to actually 1, right? This part is equals to 1, this part is equals to 1. Same state are in a scalar product between same state represent the scalar product between, not confused, will you know about that, right? Is equals to root under n plus 1 plus 2 delta n. You just look at these two equations, you just look at these two Kronecker delta part. Just notice this Kronecker delta part. When n equals to 1, when n equals to 4, for any state, these two parts never equal. This actually n or n minus 2, n and n minus 2 are never equal each other. any states, for any states. Okay, h, so this part is equals to 0. Also this part is equal, because these two states are not equal for any states. For any state, just check it, right? Just check it. So okay, we get a very beautiful result. Omega equals to 2n plus 1. 2n plus 1. So for nth state, expectations value of positions operator equals to h cut upon 2m omega n plus. Okay, 2n plus 1. We get a very beautiful result. We get a very beautiful result. Please remember this result. It is important for your competitive exam purpose. It is very important for your competitive exam purpose. Okay. So we get a expectations value of positions operators. We get expectations value of positions operator also. Also, we get expectations value. We get expectations value of square of positions operators for the state. Okay, right? I think you got get my points actually. Get my points. So now in previous class we get expectations value of positions operator with respect to ncat is equals to 0. Just check. Just check in your notebook. In your notebook, just check. How can I get these points? Because the chronicle delta functions are always equal, always unequals, always different. Because the scalar multiplications of two states are is completely different for any state. Ground state, first excited state, second excited state. It is always different. That's why the expectations value. That's why for expectations value of positions operator for nth state always 0 for harmonic oscillators. So this is another lecture. I mean, this is the another result we get in previous classes. So these two results are very important. These two results are very important for your harmonic oscillator. Now, next we calculate the uncertainty of positions. Let's take a heading. Uncertainty of positions operator. Uncertainty of positions operator for harmonic oscillator. Nth state. Okay, nth state. Nth state. Okay. For nth state, we calculate this. Okay. Uncertainty of positions operator mean delta x, right? And delta x is equals to, we already know, the expectations value of square of positions operator minus expectations value of x whole square. This is the uncertainty, right? This is the uncertainty. So we actually get the expectations value of x square is equals to root under h cut upon 2 omega n plus 1 minus 0. So this is equals to actually root under h cut upon omega, where n is the actually state. For ground state, n equals to 0. For second excited state, for third excited state, for any states, you just easily calculate the uncertainty of positions operators for harmonic oscillator. You just remember this two results. These three results are very important. Okay. I think you clear. Think you clear. If you when you solve when you solve the previous year questions, then definitely get this type of questions. Calculate the uncertainty of harmonic oscillator for first excited state or ground state or third excited state. You just put the value of n and you get in very simple way what is the uncertainty of positions operators for harmonic oscillator. Get me points? Get me points? So you get a very beautiful result, right? So this results actually decrease our time to solve any problems. Harmonic oscillators. It just take time in 1 minute. We just put the value of n and the easiest way to calculate the uncertain positions operator. Very just a result you got, right? So I feel proud. Are you excited to solve this type of problem? Don't worry, we solve those kind of problems. Yeah. Don't worry. We are definitely solve those kinds of problems. Right? We get a very beautiful result. These results, when this kind of result you apply in your exam, you feel how time is actually is saved, how time we are saved for those kind of lengthy problems. Just remember, you take a short notebook and you just write down this formula and revise, keep revise in day by day, day by day, day by day. You definitely remember it. Definitely. No, when I am preparing for CSIR NET, IIT, and this kind of exams, I just write down all the formula in a notebooks and I keep revising in day by day, day by day. One day when our exam is coming in, coming in exam, when our exam date is coming very, 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 very close, right? Then you realize most of the formula I am actually recall in when I solve when I trying to solve the problems. You know, in first time, first time, uh, when I try to solve any kind of problem, I have concept, but I have forgot the formulas. So what can I do? I make a plan to resolve this type of problems. Type of problem. Make a short note copy and write down all the formula related to IIT JAM, related to JS, related to KF for the secondary exam, right? And I'm revise all the formula every day. Or revise, I take only 20 minutes. I take only 20 minutes, right? So I think you definitely do this kind of process. Otherwise, you do not do. So otherwise, you do not do this kind of strategy in your or your preparation. You must do from today, right? Don't make a mistake. Don't make a mistake. Okay. We get a very beautiful results of uncertainty of positions operator for harmonic oscillator in a net state. In a similar way, we calculate the uh, positions operators uh, uh, expectations value of square of positions of momentum operators. So this is your homework, but this is a homework part. So for nth state, expectation value of p square is equals to, we get actually mh cut omega by 2 and plus 1. This is the result. For the competitive exam purpose, no need to derive. If you check, if you for your satisfactions, uh, uh, try to I try to derive this. Okay, you go for it. You go for it. I have no problems. But I think for your competitive exam purpose, in your competitive exam, remember those formulas necessary. Derivation is not necessary for your competitive exam purpose. Already we derived the one problems. It is sufficient. How to get this type of formula? It is sufficient, right? So from my side, my opinion is don't waste your time, right? You just recall this. Just recall this. Okay. Ultimately, in your exam, when you try to solve, when you try to solve, then formula is very important. That is, yes, yes, it is also need how to get this type of formula. It is important. It is very important. The steps are very important. That's why I derive the first case. From this first case, you definitely get an idea. How can I get this type of, right? So we just skip the derivations part. You just recombine. Just remember this. That's why I just ignore the derivations part of this form, expectations value of p square. Okay. Similarly, in previous classes, uh, we get expectations value of momentum operator for nth state is equals to. Now, the uncertainty of momentum operators of momentum operator h delta p equals root under expectations value of p square minus expectations value of p whole square. Just put those values equals to m h cut omega by 2 plus 1 minus 0 root under m. We get again uncertainty of momentum operator. Okay. Now the uncertainty product. The uncertainty product of positions uncertainty, momentum uncertainty. H and delta x delta p is equals to h cut by 2m omega root under plus 1 into m h cut omega by 2 n plus 1. Okay. So after multiplications, we get h cut by 2 n plus 1. So this is equals to n plus half into h cut. n plus half into h cut. Delta x into delta px equals to n plus half into h cut. So for ground state, for ground state, n equals to 0, delta x, delta px, h cut by 2, h cut by 2. And for n equals to 1, the x, delta px equals to 1 plus half into h cut 2 c into, it means for n equals to 0, for n greater than equals to 0, we get Heisenberg uncertainty principle for harmonic oscillators. H delta x, delta px greater than equals to h cut by 2. So when n equals to 0, delta x into delta px equals to h cut by 2. For n greater than 0, actually we get this from this equation two result actually, right? It's two result, delta x into delta px equals to h cut by 2 for n equals to 0, and for n greater than 0, this result equals to delta x to delta px. And then just remember this result. This is very important result. So delta x equal to delta p is valid for ground state only. First excited state, this is the actual expressions of harmonic oscillators. So if your exam, they are not mentioned for a specific state, for any specific state, and they ask what is the expressions of uncertainty principle, you just write these equations. But if they mentions, write down the uncertainty, Heisenberg uncertainty principle for n greater than 0, then this is the expressions of uncertainty, Heisenberg uncertainty principle. For ground state, this is the expressions for Heisenberg uncertainty principle. I think you clear. You get a very beautiful result. Okay. Okay. Very good. Get these two equations. Important examples. Right. Okay. Hmm. Okay. So these two results are very important in your exam. Next, we take another very beautiful results are very important uh, for your exam perspective. Expectations value of x to the power 4, x to the power 4, and x to the power 8. These are the very important uh, for your exam purpose, right? For your exam purpose. Okay, let's take a heading. Expectations value of x to the power 4 for harmonic oscillators for a net state. Net state. Okay, to the power 4. To the power 4. Okay. You just remember the result. It is very important. No need to calculate. We just derive this part also. Derive this part also. Hmm. I think no need. I think no need to derive this x to the power 4 for a competitive exam purpose. In semester exam, most of the time find out the expectations value of x to the power 4 for nth state. What is the expressions? Talks many times. So okay, let's try to solve this. Let's try to solve this. How can I find out this value? So actually, x cap is equals to root under h cut upon 2m omega a cap plus so x square equals to h cut upon 2m omega a cap square plus a cap dagger plus a cap dagger a cap plus a cap dagger square. So x to the power 4 is equals to x cap square into x cap square. So this is equals to h cut upon 2m omega whole square a cap square plus a cap dagger plus a cap dagger a cap plus a cap dagger square into cap square a cap dagger cap. So this is equals to h cut upon 2m omega whole square. This is equals to a cap whole to the power 4 plus a cap into a cap dagger plus a cap a cap dagger a cap plus a cap a cap dagger plus a dagger cap plus okay a cap dagger a cap dagger a dagger plus a dagger into a dagger a cap plus a dagger a dagger plus this is the approach actually. I give you an approach. How can you deal this type of problems actually? In these lectures, I am not derive all the I am not derive all the case. Right. Okay, next is equals to a cap dagger a cap into a cap plus a cap dagger a cap a cap dagger plus um, a cap dagger a cap dagger a cap plus a cap dagger a cap a cap plus a cap dagger cap a cap dagger a cap dagger a cap plus a cap dagger. This is the value of x to the power 4. For each of the case, we just calculate each of the value. The 16 term, you just calculate individually, just calculate and put this value. After calculating 16 expected 16 16 expectation value of this operator, 16 expectation value of 16 operators, you get a results. Okay. So for nth state, expectations value of x to the power 4, the result is very important, but for semester exam, this is very important how to calculate. The steps are very important. Okay, this is equals to actually we get h cut square upon 4m square omega square 6n square plus 6n plus 3. Please remember, this is very important. Most of the time they ask questions from this results. This is very important. Expectations value of x to the power 4 for harmonic oscillators. Okay, you just remember this value. Please remember this value. How to calculate this type of results actually. Okay, so we get a very beautiful results. We get a very beautiful results. How can I calculate the expectations value of x to the power 4 for harmonic oscillators? Right? So okay, finally we get a very good result. So these three uh, expectations values are very important uh, for your competitive exam purpose. You just follow each of these results. Finally, we are calculate the expectations value of harmonic oscillator, right? Expectations value of harmonic oscillators. Now give you, I give you a questions, right? I give you questions. This is tricky questions. How can I calculate the expectations value of potential of harmonic oscillator? Also, how can I calculate the expectations value of kinetic energy of harmonic oscillators? Very important. What is the questions? Questions is expectations value of potential and kinetic energy of harmonic oscillator. Harmonic oscillator, right? We are already know the potential energy or V of x equals to half of m omega square x square. expectations value of this harmonic potential energy for nth state. For expectations value of potential energy, this is equals to omega square n x square. We already know what is the expectations value of x square. Is equals to into h cut upon omega n plus 1, right. Okay, this is equals to m is cancel each others, omega is cut omega by 2, omega by 4, n plus 1, cut omega by 4 to n plus 1. You don't try to remember this result, you follow this. Don't try to remember this. You just follow the steps. How can I calculate the expectations value of potential energy of harmonic oscillators? Okay. Okay. We take an example. Let us consider an potential energy of harmonic oscillators. H V of x equals to half of m omega 1 square plus half of m omega 2 square to the power 4. This is the potential energy. Calculate expectations value of potential energy. Expectations value of potential energy. How can I calculate? This is a very easy approach, right? For nth state. This is equals to half of m square n x1 square plus m omega 2 square n x2 whole to the power 4 state is equals to half of m 1 square into cut up 2m omega 1. Yeah. 2m omega 1. 2n plus 1 m omega 2 square. This is equals to cut square 4m square 6n square plus 6n. Finally, we get h cut omega 1 upon 4 2n plus 1. This is equals to omega 2 square is cancel each others. So this is equals to cut square 8m square. This is the way calculate the expectations value of positions operator. So this expectations value of x1 x square for an nth state, expectations value x to the power 4 for n state is very important result. If you don't remember this results, so its derivation is time consumed, it's take time, right? So please remember these two results, harmonic oscillators. in your examination, the most of the time they ask this type of questions, right? This type of questions. Okay, think you clear? I think you clear. In a similar way, uh, expectations value of kinetic energy. Kinetic energy. So we know kinetic energy is equals to E square upon 2m. Right? Kinetic energy is equals to square upon 2m. So if I try to calculate the expectations value, kinetic energy operator for nth state, is very easy, right? 1 upon 2m square and get this is equals to 1 upon 2m m h card omega upon 2 2 1. So m cancel each others, omega upon 4 no, n plus 1. We just notice this. We just focus these two equations. Just we get a very beautiful result. We get a very beautiful results. For inner state, expectations value of potential get omega upon 4. This is equals to h cut omega by 2 plus so half 2 plus half h cut omega. Okay. Again, for inner state, expectations value of kinetic energy operator, we again get h cut omega upon 4 n plus 1 is similarly equals to half n plus half. N plus half h cut omega, this is nothing but the expectations value of Hamiltonian operators, energy operators for nth state. It is actually represented these two actually represented what? Expectation value of total energy operators. Value of energy operator in in that is like in will get this type of result, right? This is equals to what you get up h cut omega. So the expectations value, sorry, okay. Total energy operators. is nothing but n h cap n is equals to what we get in plus half. We get a very beautiful result. Expectations value of potential energy operators, expectation value of kinetic energy operator for harmonic oscillator. This is nothing each thing but up of expectations value of total energy operators. We get a very beautiful result. We get a very beautiful result. Very easy, right? We get a very beautiful results. Okay, and so the expectations value of the potential and kinetic energies are equal to are equal to half of the total energy. Half of the total energy. Half of the total energy. So this result is called real theorem. Called real. Okay. So lecture number 6, we discuss some important results. Okay. In your next lectures, we discuss some advanced. We discuss some problems related to just examinations of harmonic oscillators, and then we go to actually in lecture number 7 we discuss some previous year questions. Up to these lectures we covered the theory portions. We are completely covered theory portions for uh, uh, just TFR gate examinations, but for CSR net matrix representations of harmonic oscillator operators is very important. In next after few lectures we discuss these lectures also. This lecture are not important for just an IIT jam examinations. Up to this part, is importance for all exam. Importance for all exam. But one lecture I will discuss the matrix representations. This operator. This is not important for IIT jam, but it is important for just examinations. TFR exams also, but it is also it's very good important for GATE and CSR net exam. But before that, first discuss some previous year questions. Okay. Okay. Again, thank you and thank you for watching this video. And please subscribe and like my channel if you get benefits from this lecture. I again say you this lecture is very good, very important for exam purpose. You definitely feel when you solve your previous year question. Okay. Okay. Thank you. Happy learning. Keep learning. Meet again in another lectures, another sessions with some previous year questions. Okay.